the video lecture series on Chemical Engineering Thermodynamics 2. I am Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. So let's continue with the chapter number 3, which is reaction equilibria. So in this lecture, we are going to discuss about the evolution of equilibrium constant scheme. So there are mainly three methods for the find out the equilibrium constant. So let's start with method 1. So there are mainly three methods to find out the equilibrium constant. So first method, which is a experimental method, equilibrium constant K may be calculated from the experimentally measure from the equation that can be given by K is equal to pi of AI whole raised to Vi, which is our equation number 1. If the K value is known, then it is a substitute in equation like ln K is equal to delta H dash upon RT, negative sign of delta H dash upon RT plus delta alpha upon R ln T plus delta beta upon 2R into T plus delta gamma upon 6R T square plus A. So this is our equation number 2, where A is a integral constant. So using this equation, we can find out by putting the value of K or putting the value of enthalpy change, we can find the value of K. So here just we have to put the value of enthalpy change and value of R, and temperature is known, value of alpha and beta. We already discussed how to find the value of delta alpha, delta beta and delta gamma in CT1 chapter number 3, which is a heat effect. Okay, so from that equation we can find out the value of K. So now let's discuss about the second method, which is so let's first write method 2. So if the value of K and delta H naught T known, then it's directly we can calculate delta H naught using the equation. So delta H naught, that can be given by delta H naught T is equal to delta H dash plus delta alpha T plus delta beta T plus this is a T square delta gamma T cube upon 3 upon 2. So again this equation comes from CT1 chapter 3, which is a heat effect. Okay, so using this equation we can put the value, we can find out the delta H naught, and using this delta H naught we can find the ln K, which given by ln K is equal to minus delta H naught upon RT plus delta alpha upon R ln T plus delta B upon 2R to T plus delta gamma upon 6R into T square plus A, where A is the integral constant. So in previous we can experimentally we can find this all value, where here we are just using the literature value, we can find the ln K, or can say that equilibrium constant. Now let's discuss about the method 3. So in third method, this method involve no directly experimental measurement for the equilibrium constant, and therefore this is the most convenient and widely used method. The method make use of thermodynamics data, usually in form of the standard heat of reaction of or can say that delta H naught and standard gift free energy delta G naught. Okay, so then our delta H naught of T is becomes delta H dash plus delta alpha t plus delta beta t square upon 2 plus delta gamma t cube upon 3 and so on. Okay, so using this equation we can find out the delta H naught, and using the delta H naught and the standard gift free energy, using this equation we can find out the delta H naught. Okay, now we are going to find out the delta G naught to find out the value of K. So delta G naught, that can be given by summation of Vi into Gi naught. Okay, so delta G naught is equal to, can say that Vi, which means stoichiometric number. Stoichiometric number of reactant is a negative, and for the product is a positive. Why is negative for the reactant? Because the value of stoichiometric number or stoichiometric coefficient is a negative for the reactant, because react going to consume during the reaction. Okay, so mass of reaction reactant is a decrease, so can say that the value of stoichiometric number is a negative for the reactant, and value of stoichiometric number and stoichiometric coefficient can say that is a positive for the product, because during the reaction product is formed and mass of product is getting more and more. That's why stoichiometric number of a product is a positive. So if we are going to rearranging this equation, so we can writing like this: Vi of delta G naught of I, this is for the product, minus Vi delta G naught for the reactant. Okay, we are taking the minus commonly, so here the value of stoichiometric number is always positive. That's why we put this Vi in this both bracket. So standard gift free energy of reaction is the algebraic sum of the free energy of formation of product minus algebraic sum of the free energy of formation of the reactant. When eliminant enter to the reaction, it is a standard free energy of formation may be taken to a 0. So using value of delta H naught and G naught, we can find the value of K using various equation like ln K is equal to minus RT, sorry, it becomes delta G naught is equal to minus RT ln K. Okay, so using this value we can find out the ln K, and again we can using the one top equation, using the one half equation, or can say that effect of temperature on equilibrium constant, we can find out the delta H naught and find the value of ln K. So this is how we can find the value of ln K. So what is the one half equation? One half equation that can be given by d of ln K upon dt is equal to delta H naught upon RT square. So putting the value of H naught using this H naught, we can find the value of delta ln K. So here in this lecture discuss about the evaluation of equilibrium constant. There are mainly three methods for find out the value of equilibrium constant. In first method we are going to use the experimental data. During the experiment we are going to find out the delta H dash, alpha, beta and gamma, that can be find from the chapter number 3 of CET1, which is a heat effect. So using the Hess law we can find this all the stuff and calculate the value of K. Okay, then method 2, which is not experimental method, but we are going to use the same equation as a Hess law, or can say that chapter number 3, which is the heat effect of CET1. So using this equation we can find out value of delta H naught, and putting the value of delta H naught in this equation we can find out the value of ln K using this equation, where A is a integral constant. Okay, Now then discuss about the method 3, which is in which we are going to use the value of delta H naught and delta G. Okay, so if we are getting the value of delta H naught, we are just putting the value of delta H naught in one of equation and we will get the value of ln K. And if we are getting the value of G naught, gift free energy, is equal to summation of VIGI, which where VI is a stoichiometric number. So stoichiometric number is a negative for the reactant and positive for the product. So it's negative. So we can say that summation of VI of GI of all products. So can say that gift free energy of all product minus gift free energy or standard state gift free energy of reactant. So using this value, we can find out the delta G naught, and this using this delta value of delta G naught in this equation, we will get the value of ln K. So this is how we can find the value of ln K. So this is all about this today's lecture. In next lecture, we are going to discuss about the heterogeneous reaction such as a solid gas reaction and liquid gas reaction. So we will discuss about the various heterogeneous reaction, effect of fugacity on this solid gas reaction, and how the fugacity or activity used to find out the equilibrium constant in a heterogeneous reaction. So we will discuss about the heterogeneous reaction in the next lecture. So this is all about today's lecture. I am completing my lecture here. Thank you.